I'm going to talk to you about some new estimates of carbon that is stored in Arctic tundra and in permafrost soils. So the first thing that we should do is we should take a view from the top. I don't know if many of you have taken a look at the globe from above the North Pole, but this is what the Arctic Ocean and the land mass looks like. The region there that is colored is the Arctic tundra. We define the tundra as being treeless. It is not absent of woody plants, though. There are lots of woody plants. There are shrubs, lots of shrub species in the Arctic tundra, but no trees. That's how we define it. We see large expanses of tundra in Russia and in Canada, and then other regions of tundra in the United States and also in Scandinavia, and in Greenland at the edges off of the Greenland ice sheet. You should note that the tundra region is in close proximity to the Arctic Ocean, so it's either perennially or seasonally frozen water. So it's very strongly influenced by the sea ice dynamics that we are seeing there. Approximately 13% of the Earth's land area is Arctic tundra. I'll focus now on the tundra region of North America. And we split the tundra into different subzones. We have subzone E, which is the warmest and most southern of the tundra zones, and go up to subzone A, which we also call the polar desert, which is the most northern and coldest region of tundra. What's interesting to note is that if you want to get to the high Arctic, you really need to leave the United States. Okay, Alaska basically gets you just into the center of the Arctic tundra. In North America, most of the Arctic tundra is on the Canadian archipelago. I'll just give you a tour of some of the different tundra subzones to give you an idea of what they look like. The tundra in the southernmost subzone, subzone E, we call it the low Arctic tundra. It's pretty lush. It has a lot of vegetation. It has 100% vegetation cover. It is dominated by some shrubs that are quite tall. They can be a meter tall. They can be a meter to 2 meters tall. If we move a little bit further north, it may start to look more like what you might expect from Arctic tundra, but still there's 100% or close to 100% of vegetation cover on the ground. There's still a lot of shrubs in there, although they're much shorter and they're a little bit more difficult to see. These regions in subzone D, also part of the low Arctic, they look a lot like prairie of Montana or Wyoming that you might see in the western US. Now we go a little bit further, we get into subzone C, which is effectively the center of the tundra, the middle of the tundra, and it starts to look more barren, or what you might expect. There is a lot more bare ground. There is much shorter vegetation, although you still see woody plants. There are still shrubs that are now growing much closer to the ground to try to capitalize on the warmth of the surface. You see in subzone C, we see a lot of patterned features that are quite common in Arctic tundra, and they occur in permafrost regions and also in areas where the top layer of the soil will freeze and thaw every year, and they become very dominant in the center of the tundra. Going even further north, we move into a region that we call the high Arctic, and in the high Arctic it's quite barren. You have a mix of barren ground and vegetation. You also see a lot of pattern ground features that are caused by the freezing and thawing of soils every year. And surprisingly, there's, well, maybe not, but there's still quite a bit of vegetation in the high Arctic, and there are shrubs. There are woody plants that still exist there. There are two species of shrubs. One is evergreen and one is deciduous that still make it in subzone B up about 75 degrees north latitude. Even further, we get to subzone A, which is we also call it the polar desert. Still plenty of vegetation up there mixed in with the bare ground, and we define the polar desert as finally having the absence of woody plants. it might be hard to see, but those yellow flowers up here are poppies that seem to grow very well at this polar desert site on Ellefringus Island in Canada. Okay, to give you a few definitions, the Arctic tundra is underlain by continuous permafrost. Permafrost is permanently frozen ground, and Vladimir Romanovsky will talk to you in more depth about permafrost. The permafrost region, as I'll explain later, it extends beyond the Arctic tundra biome, quite a bit beyond the Arctic tundra biome. You get regions of continuous permafrost, discontinuous permafrost as well. Another term that I should define is the active layer. Okay, the active layer is the ground that is between the surface and the top of the permafrost, and that is the layer that thaws every summer and then refreezes in the winter. The active layer can range from tens of centimeters to several meters in depth. The big carbon story in the Arctic tundra is below ground, particularly where you find dense vegetation. These two soil cores here were taken very close to each other. One is underneath vegetation, the other was unvegetated, and you see that the soil core under the vegetation developed a thick, rich 20-centimeter organic layer of dead organic carbon. But our estimates of the amount of carbon that's stored in Arctic tundra soils have been made in the past, typically from relatively shallow samples. And we know now that there's a lot of carbon that is stored at depth in these soils. A new paper that recently came out in Nature, the lead author is Chen Luping, examined the stocks of soil organic carbon in the North American region and found that they were substantially higher than we had estimated in the past. If you look at this soil profile here that is dug down to a meter, you see the top 50 centimeters is probably the active layer that's thawed, and you see some pockets of dark blackish material that is carbon. But below 50 centimeters, this is where the permafrost is, and you also see quite a bit of dark material of organic carbon stored in the permafrost.